All right, let's get right into the high-stakes world of heavy vehicle diesel mechanics. We're not talking about guesswork here. We're talking about a professional code, a set of principles built on some seriously deep knowledge. So let's break down the 5 core ideas that every top-tier technician absolutely lives by.
Okay, let's just put ourselves in the shop for a second. Picture this. A massive 40-ton rig rolls in. The engine's running rough, it's losing power, and you know it's a complex fuel system fault. The clock is ticking, the pressure's on, so what's your first move? Where do you even begin?
Well, here's the thing. The answer isn't to grab a wrench. It's not to immediately plug in a scanner. Nope. You start with the most powerful tool you have, your own knowledge. A real pro knows that the repair actually begins long before your hands ever touch the engine.
And that leads us right into our very first principle, and it's a big one. You have to know your fuel system. I mean, inside and out. This is the absolute non-negotiable starting point for any serious diagnostic job.
You see, a heavy diesel engine isn't just a heavy diesel engine. There's a whole world of different systems out there. Are you looking at a classic distributor or inline pump? Or is it a modern, high-pressure common rail system? Maybe it's an electronic or hydraulic unit injection system, what we call EUI or HEUI. Figuring out which one you're working on is critical because that one detail dictates your entire approach.
And here's exactly why that matters so much. If you misidentify the system, you could go down a completely wrong diagnostic rabbit hole. I'm talking hours wasted and a lot of the customer's money spent chasing a ghost. The takeaway is simple. Know the system before you do anything else. Now, for our second principle, the tone gets a lot more serious. This isn't just about being efficient anymore. This is about your life. We are talking about high-stakes safety procedures. Take a look at this number, 200 megapascals. Let that sink in for a second. That's the kind of pressure we're dealing with inside a modern common rail diesel system. To give you some perspective, that's like having a full-grown professional linebacker standing on the tiny tip of a hypodermic needle. It is an absolutely incredible amount of force.
And this is where it gets truly terrifying. This is not some theoretical risk. At 200 megapascals, diesel fuel won't just spray on you, it will blast right through your skin. We're talking about catastrophic internal injuries, a fuel embolism. This is a life-threatening medical emergency, plain and simple.
And here's the kicker. That danger doesn't just vanish when you turn the engine off. That insane pressure stays stored in the system, waiting. Following the correct depressurization procedure isn't just a good idea. It is an absolutely non-negotiable step to prevent a life-altering or life-ending injury.
Okay, so once we're absolutely sure the system is safe, we can move on to principle number 3. And this is where the technician really becomes a detective, following a trail of clues to hunt down the real culprit.
So let's take a classic case. A truck rolls in and it's blowing excessive black smoke. What does that actually mean? Is it a worn-out injection pump? A faulty turbo? Could the timing be off? Or could it be something as simple as a blocked air filter? The symptom is obvious, but the real cause is hiding.
So how do you solve it? Well, you don't guess. You follow the evidence, using a systematic sequence. You start by assessing the smoke, then you test the low-pressure supply, then the injectors, then the whole air system. This methodical process is what stops you from, say, replacing a multi-$1,000 component when the real problem was a simple $100 fix.
All right, so you've done your detective work, you've found the culprit. Now comes the delicate part, which brings us to principle 4, the art of the repair. This is where precision is absolutely everything. And out of all the adjustments you can make, you could argue that injection pump timing is the most critical of them all. It's literally the heartbeat of the engine, and getting it perfect affects, well, everything.
And you can see here, the stakes could not be higher. Get the timing right, and you've got full power, great fuel efficiency, and a long, healthy engine life. But get that timing off by just a few degrees, you're looking at major engine wear, terrible emissions, and eventually a premature and catastrophic failure.
So you've done the diagnosis, you've completed the precise repair, job's done, right? You can pack up the tools? Not so fast. Principle number 5 is all about closing the case for good, verifying the final fix.
The job is not finished until you've run a complete post-repair protocol. You have to check every single connection for leaks, and not while it's resting, but at full operating pressure. Then you've got to assess the engine's performance to make sure the original fault is actually gone. And finally, you document everything.
And this right here is such a critical point. A fuel fitting can look perfectly fine when the engine's off, but once you get that 200 megapascals of pressure coursing through the system again, even a tiny flaw can turn into a dangerous leak. We're talking a serious fire risk or an environmental hazard just waiting to happen miles down the road.
And that really brings us to the final, most important takeaway. For a professional diesel technician, the job is never just about fixing a piece of machinery. It's about taking on this huge responsibility for the safety, the reliability, and the efficiency of these massive vehicles that, honestly, our entire economy depends on. It's not just repair, it's responsibility.